In this video, I am going to show you simulation of a bouncing ball with air drag using Visual Python. Firstly, I want to tell you a story about Newton, Pascal and Darwin. Once upon a time, there were three men named Newton, Pascal, and Darwin. On a sunny day, they were playing hide and go seek. It was Darwin's turn to count, so he covered his eyes and counted to 30. Pascal ran off to hide, but Newton paused and instead of running, drew a square in the sidewalk around him. When Darwin stopped counting, he saw Newton right away and said, "That's no fun, Newton. Why didn't you hide?" And Newton replied, "No sir, I'm not Newton. I'm 1 Newton per square meter. I am a Pascal." Now, back to our topic. In the first line, we type from VPython import to declare that we are using VPython module. In all simulation programs, we will have this line as the first line of our code. Since we are simulating some physics phenomena which can be seen everywhere in our daily life, we will have to set up some physical constants. Okay, now, someone might ask, in what units are those physical quantities? For convenience, we will use SI units for all the physical constants. In order to make our code more readable, we will need to put some comments after our code in the same line. The hash sign is used before comments because texts after the hash sign are not parts of the program, so the texts or number after the hash sign will not have any effect on our code. Next, we open up a window named Scene. It is a canvas with width 500 horizontal pixels. In the simulation world, the default view angle for x-axis is positive, which means to the right. For y-axis, positive direction is to the top and lasts. For z-axis, positive direction equals to point out the screen. Vector x, y and z means a 3D vector, and we will type VEC instead of vector for convenience. The 3 digits in the parentheses represents direction x, y and z from left to right, respectively. The center enclosed by the parentheses is the position vector of the center of the simulation world. In the next line, we set up our background color. In the parentheses, from left to right, represents color red, green and blue. It is scaled from 0 to 1, which indicates the strength of the color. For our background, we have half of color red and half of color green. The tip for this line of code is always setting this attribute to some background color, otherwise, the background defaults to be color black. This makes the results difficult to be seen, especially when using a projector. I align my simulation to be on the left because we will have a speed versus time graph aligned to right later. To show a flat floor, we draw a box of length 30, height 0.01 and width of 10. Length, height and width represents x, y and z axis, respectively. In Python, a point B means the attribute B of A, and we have color blue for our floor. Okay, now, let's draw a ball. We will draw a sphere and name it ball. Radius means radius of the ball and it equals to size, which we have already declared the value of it at the beginning. Yes, I want my ball to be color red. Attribute make trail equals to true, making a trail of the object, and we set the thickness or radius to be set to 1/3 of size. In the following line, we create a graph window called oscillation. It is 400 pixels on screen width and it's aligned to the right. The funct is an abbreviation of the word function. It creates a curve plot to be drawn in oscillation, with color blue and line width equal to 4. In this part, we assign some initial values to these variables which we will use later. The initial position of the ball will be 15 units to the left in x-axis and 0.25 to the top and not pointing into or out the screen. The initial velocity of the ball will be 20 times cosine theta in x-axis, 20 times sine theta in y-axis and no value for z-axis. T represents time and we set the initial value to be 0. dt sets how much real time elapses in one step in the following while loop. The size of dt depends on the time scale of the simulation events. Maxima represents the highest point of ball in the motion later, while ball path represents the distance of the ball's motion. Before entering the while loop, we need to set up a condition for the loop. If the situation does not match the condition, it will not enter the loop. As for this assignment, the requirement is the motion of ball for the first 3 times hitting the ground, and condition for this while loop is clear, which count should not larger than 3. Rate means how many times it runs per second. In the first line of while loop, I assign the vector of ball's position to an object named ballpoint and it will play a role as a single value memory. I will explain to you later the reason why we need a value memory. In the next line, ballpoint v represents the velocity of the ball and we have the formula of calculating ball's velocity after the equal sign. In this situation, as the ball moves, it decelerates in the rate of gravitational pull, and don't forget, the air resistance will also slow down the ball's motion. Ballpoint pose represents the position of the ball, and it varies with the ball's velocity, since it changes during every dt, so I need an object named ballpoint to save the previous position of ball to do my calculations in the later part of my code. Another object named ballpath, it represents the distance of the ball in this motion. The ball moving in a curve instead of a straight line makes it a little bit difficult for me to calculate the distance. Therefore, I think that cutting the curve into uncountable pieces of triangle, and the total sum of hypotenuse of these small triangles will be the distance of the ball in this motion. Instead of using Pythagoras' rule to calculate the length of hypotenuse, I take the difference between magnitude of the latest ball's position and the previous ball's position. While the ball hits the ground, how do we make it bounce back? When the ball hits the ground, it means the ball's position and y-axis will be smaller than the sum of size and height of the floor, and the velocity of ball in y-axis will be no larger than 0 also. All we have to do is to assign the negative value of the ball velocity in y-axis to the ball velocity as it hits the ground once, or to say enter this if loop once, the count will add on 1 every single time. We have another loop in the big while loop. This small loop is to find out the largest value of the ball's height. While the value of maxima is smaller than the value of ball position in y-axis, we will assign the value of ball position to maxima. As the while loop runs, the object maxima will save the largest value of the ball position in y-axis, because if the value of maxima is larger than ball position point y, it will not enter the while loop. The t equals to t plus dt, means the t will accumulate as the while loop runs through its body every time. The way of writing this line in t positive equal dt does the same thing as well. To have the graph plotted, I need an object to calculate the value, or to say magnitude of the ball's velocity. I named it speed. As you can see, after the equal sign, there is mag, magnitude of ballpoint v, which is ball's velocity. If we want to calculate the value of something, without considering its positive or negative sign, we use mag in a set of parentheses to help us out. The last line in the while loop body, the code is to plot the speed versus time graph we wanted. As we named function to funct in earlier time, add point plot means attribute graph plotting of the function. Inside the parentheses, we declare what variables we wanted as our x-axis and y-axis. We have t time as our x-axis variable and speed as our y-axis variable, since we want to plot a speed versus time graph. Last but not least, we print the message we wish inside the canvas. As you can see, text equals to a sentence, and inside the quotation marks, is what we wish to be shown in the simulation world. After that comma, we declare the position of the sentence in vector form. In the following line, there's no big difference except the usage of str, which means string. In the parentheses, we put maxima because it's a string and we want it to be shown in the canvas. If you're not too sure which kind of variable is it, you do it this way. Print parentheses, type parentheses and maxima. The result will be shown after you click on the Run button. The other 4 lines do the same thing as the first 2, which I have already explained. I have done the optional part of this assignment, which is to simulate the motion of ball in a free fall with air drag. I will not explain the first few lines of my code since it has no big difference with the bouncing balls one. The only difference is I changed the value of ball initial position and ball initial velocity. Let us enter the while loop now. For the ball velocity, it slows down due to gravitational pull and air resistance. We have the formula of calculating it after the equal sign. In the next line, the value of position varies with the changing velocity. I guess you already knew the meaning of t plus equal dt, and so for the speed function plot. For this optional part of code, we print a speed versus time graph as well. Inside the parentheses, you can type ballpoint v.mag instead of speed if you are not feeling to declare another object, which in this situation, I have an object named speed declared. In the last few lines, we print the final velocity of the ball's motion inside the canvas with units in meter. This is all of my VPython code. I wish that my explanation is clear enough. Thank you for watching and happy coding.